Hi guys, in this video we will be refreshing on calculating the center of mass and center of rigidity of the floor plate. We've got a floor plate here 6 by 10 and we've got a void here. So to calculating, first of all, calculating the center of mass is just a relationship of your mass and times your horizontal distance to your origin. So in this case here, we just assume that we've got origin at the corner here, which is 0, 0.0, and this is our origin. And we have my x-axis and my y-axis. And to calculate the center of mass, as this is the equation here, we have the individual weight times the individual distance to the origin. That's di, the distance to the origin, the center of the individual weight to the origin. And Wt is the total weight. In this case, our total weight, we can get it first, which is the slab weight. You have to subtract your void, 20 kilonewtons. You get your total weight, Wt is 80. And then we just need to work out for the x direction, center of mass in x-axis. So our individual individual slab weight would be 100 times, assuming the rectangular is the center of the center of mass is the center, so 5 meters away from the origin, so times 5 meters, and also subtracting my void here, which is 20 kilonewtons, times here I've got that is at the center of my mass of void is 3 meters away from my origin, so times 3 meters, so divided by your total weight 80, and that you can do the math. That gives you the x-axis of your center of mass. So same for the y-axis, we will be looking at the uh, floor plate into the y-axis. So we have the same thing. We have 100 times what would it be the distance to my x-axis, which is looking down. So I have my that is 3 meters, so 100 times 3, and subtracting my void, that is also 3 meters as well, and divided by the total, which is 80. That gives you the y-axis. So in this step here, we've got our center of mass for x and y. And for the rigidity, this comes a little bit different. So the rigidity that is for if we got the floor, the frames, they are the same type on top of the floor. For instance, whether you're using concrete shear wall or timber shear wall, as long as the same type of a material, then you can basically assume that essentially their stiffness, the stiffness is proportional to the length of the square. So in this case here, you can have you see that the wall A and the wall 3, they have the same stiffness, and wall 2 and wall 4, they have the same stiffness because they're the same length. So in this case here, we can work out, it's similar to working on center of mass. It's just the swapping in terms of using the Wi individual weight, you will be using individual stiffness, which is the L squared. So working on the center of rigidity for x-axis, center of rigidity, that is equals to, I'm looking at my wall 1 and wall 3 in my x direction, because those two perpendicular walls to my x direction. So my wall 1 is L squared. I've assumed this is 4 meters. So I'm going to say 4 meters squared times what's the distance to my origin is 0. And plus my wall 3, that is a 4 meters squared, times what's the distance to my origin, that is 10 meters. And divided by the total stiffness, which is a 4 plus 4 squared. And this gives you the center of rigidity for x-axis. And the same thing, we can do y-axis, center of rigidity for y, and we'll be looking at the walls perpendicular to y-axis, which is the 2 and 4. So for 2, we assume that it's 2 meters long. So my stiffness for my wall 2 is 2 squared times the origin to my x-axis 2 is 0, and plus my wall 4, same thing, that's stiffness 2 squared times the distance to my origin, x-axis, the vertical, that is 6 meters, and divided by my total stiffness, which is 2 squared plus 2 squared, and then that gives you the center of rigidity. So by doing these steps, you get your center of mass and center of rigidity. Yeah. The only thing to be aware of is that if you have steel frames or eccentric brace frames or portal frames instead of the walls, then the stiffness won't be the L squared. The stiffness is going to be proportional to number of bays of your portal frames. If so, for example, you have 4 portal frames on one end, and on the other have 3 portal frames, then your stiffness on this side would be 4, and your stiffness on the other end would be 3. So it just depending on, you just be counting on number of bays, that will be your stiffness, and your total stiffness would be just adding summation of number of bays. You have total say 4 and 3, so your total is 7 bays. Your total stiffness is 7. So this is the how to calculate center of mass and the center of rigidity, and it is important to do and to get your torsional lever arm. This is the critical step. So yep, thanks for watching.